Hey guys, welcome to week 3. Was going to go on video, but for some reason I cannot get the video to work on my laptop. So there goes that. And then I was going to do the Zoom, and then for some reason Zoom changed their configuration. You have to do a single sign-on, and anyways, here we are. So week 3, module 3, welcome. Hopefully everyone had a great week. Do have something good planned for this week. We're going to try something a little bit different. I am definitely interested in getting us all involved in doing different assignments moving forward. So with that said, we'll go through, what I'll do is a rough through what was expected for this week. This class is supposed to be on Wednesday, September 21st, or not September 21st, Wednesday, September 14th. So this will be more of an online this week. So I want to go through what is expected of you. So the first thing is summary. This is expected each week. Just continue to do what you do. Write a nice little short summary. It could be a summary of the lecture. It could be a summary of what you read for the week. That's completely up to you. Just provided notes on your summaries this past week for at least module 1, not module 2 yet. If you have questions, you know how to reach out to me. Another thing is just to let you know, since I do not have regular scheduled meetings on Monday, Tuesday, or Wednesday this upcoming week, I've sent an email for Thursday. I've opened up 6 hours of available time. So book within any of those times frames. They'll be available. Getting into the discussion for the week, we're talking about fiber optics and cable coaxial cable. We talked about this a little bit in our last module. Some of you have fiber optics, so some of you have Fios, and some of you have cable modem. What we're talking about is what is quicker. We've talked about Fios being quicker, but do some research, Google it, see what you find out. All right, module 3. Getting to the assignment, this is going to be different. Now, we have, if you look at the people in our class, we have 12 students in the class. Now, I don't know if some of you know each other. You may not. I don't know. This assignment is going to be different because it could be a joint assignment. So if you have someone in the class that you want to team up with on this assignment, I'm fine with that. If you want 2 or 3 people, just limit it to 3 people at the most. If you want to do it by yourself, that's fine too. Ultimately, what you're going to do is you have this assignment that I'm going to present here, and you are going to present it on, which would be module 4, September. Oh, these dates are getting back out of me. So September 21st, you'll present it to class, a PowerPoint. So assignment's a little bit different, but I think it's 100 points. And so I'm going to go through it. So your task for this assignment is to take a rough cut at a design and installation requirements of a small network. You may work, as I mentioned, in a small group or individually. It's up to you. The context of that, and that's all right in here. Context is a tenant is moving into a currently empty office space on one floor of a building. The space has typically the office construction. So drop ceilings, drywall, concrete floor. So, and why this is important, if you have time, go to like Home Depot or Lowe's. Those buildings are made out of concrete. Go into the back wall and try to use your phone and see what type of access you get. The dimensions of the space are 60 feet by 100 feet. And there's a schematic on page 2. It kind of shows you a diagram. A wiring closet space is present. So see the schematic. We talked about wiring closets in this class. 25 wired desktop computers will be placed into this location, along with 5 network printers. 3 servers will be in the wiring closet. The assumptions here are all necessary electrical connections are already present. You don't have to worry about that. This network will be isolated from outside world. No need for firewalls, demarcation points, etc. So don't worry about that. 25 computers will be distributed evenly in the 5 shaded work areas in the diagram. Each work area will have one printer. All network installation and testing tools are available and do not need to be purchased. You do not need to consider the computer or server equipment, just the network equipment. So we'll go to the rest in a second, but if you look at the schematic, here it is. Each office is going to have 5 printer. Each is going to have their own printer, so you kind of get an idea of this. Assignment number 1 is worth 20 points. State a project plan for all the steps you feel would be necessary to complete the network. A project plan lays out the steps that are necessary to get the job done, and in what order must be done. So identifying what are your, first of all, do some brainstorming if you're doing it individually, if you're doing it, or even within the team. Start identifying things that, I say brainstorm and think about things that you need. And then figure out what happens first, like step A, step B, step C. That's important. It's like, for example, if you are going to go get your car wash, what are the first things that you do when you wash your car? Well, first thing you do is obviously you put money in the machine. You rinse it off before you wash it. Then you wash it. And maybe you use a chamois or something like that to dry it off manually. So those are chosen in order, and that's how this works as well. So the first part is coming up with a project plan. Have you ever built a project plan? Well, if you're not sure, plan for agile projects. You could come out to Google and do some research to see how to create a plan. There's, as it tells you right here, there's like dependencies, milestones. This is not that in depth. So maybe agile is not the best bet for, we'll say, for projects. All right, so as you can see here, this is not a business class, but you could do some Google searching and see what people said about product charters, statement of work breakdown, etc. You could get an idea here of how to build a plan. But ultimately, what we're looking for here in this assignment, it doesn't have to be robust. Just provide a plan. Maybe write it down in Word, screenshot it, and put it in your PowerPoint. That's up to you. But make a list of items that you have to complete from beginning to end. Part 2 is worth 50 points. Identify the materials and components that you would need to complete the job and provide a cost estimate. So once again, go out to Google, identify the items that you're going to use, get an idea what the cost is. Go to CDW, go to Best Buy, whatever. To complete this, you'll need to take your best shot at specifying the materials and components, and then do research for pricing on the web. Don't worry about trying to pick the ultimate or optimal equipment here. The goal of the assignment is to let you take a stab at some design work. Explain your choices in a reasonable detail, meaning don't just say that, oh, you're going to go buy a big spool of bulk cable. State what type of cable. Why did you choose that type? Maybe you searched it on the internet. How much is it? Then also include labor costs. Labor costs do not need to be included here. Estimate the amount of cable that you would need based on the calculations of the rough distances between the closet to where the workstation might be. The more details you provide as to how you derived and what you need to buy, the more you help me understand your thought process. Provide the reasons for your choices. Ultimately here, create a PowerPoint slide presenting your work. You'll come up in front of the class and present your work to the class on Wednesday, September 21st. And please submit your PowerPoint and or Google slideshow beforehand. Here's your diagram, and it just talks about the rubric. So the 20 points for assignment part 1, 50 for part 2, and the third part is a presentation aspect. Everyone has to participate. If you're in a group and there's 3 people up there, not one person is going to be the one person talking the whole time. Everyone has to play a role in this. And also at the end of your PowerPoint, provide the participation that went into it. Who did what? What was their role? So this is assignment 1. I think this, the first 2 weeks have been more like read this, do that. I wanted to make it more contextual. I wanted to make it more more detailed, and this is actually a good assignment. You're starting to think about how to set up a network. Remember, I told you my story where I got laid off from my job. I started a company where I was an IT manager, and one of the first things I had to do was fix their network because there was a bunch of computers that were not working. And to be honest with you, a lot of and it was something new for me personally because I'd never been involved from that aspect. I'd always been writing code. So Google was helpful because I had to come up with a business plan. I had to identify what was broke and needed fixed. I had to identify how we were going to resolve it. The immediate thing for me was to figure a way to fix it for now. And then ultimately later on, my bigger picture plan was to replace the equipment with higher end equipment that would be more worthy to work. But in your presentation here, you don't need the best of the best. You just need to make it work and just see what thought process goes through. So that is the assignment. If you have questions, email me. I will answer them. So let's go through the lecture. So I'm not sure if I'm just going to, instead of making it real big and losing it, because if I do it as a view, I might not. Okay, maybe I do have it. All right, so let's talk about wireless. So a typical network computer consists of a twisted pair for LAN network connections, and we talked about that. So those are your Ethernet cables. Fiber optic cable to interconnect the LANs. Wireless based on the IEEE 802.11 wireless standard. So that's a wireless standard using your Wi-Fi. The advantages include your user mobility in the workplace. Our smartphones have access to this. A cost-effective networking media for use in the areas that are difficult or costly to wire. So benefits of wireless network. All right. So obviously wireless networks in a workplace are numerous. They've grown since I started in technology. In order to provide wireless connectivity, the network admin must make sure that the network service is reliable and secure. So you wouldn't want to run a wireless network. So if you look on your phone and you go somewhere and you look at Wi-Fi connections and you see an open port that doesn't have a lock on it or something like that, that just means it's an unsecure network. Early on when internet was available, a lot of us didn't even think about it. We were like, cool, Wi-Fi, free, I'm jumping on it. But from how things have changed over the years, you got to be very careful on doing that. I try to sway away from that. If you do that and you have a VPN on your phone, it might be recommended to do that because there's a lot of things could happen. There could be something called a man in the middle. There could be people spoofing, creating mirror internet Wi-Fi points. I've seen it happen at the airport. And it's just to steal your information at the end of the day. So you gotta be careful. Providing a reliable network services means that the network admin must have a good understanding of wireless LAN configurations and technologies. And this comes with a lot of experience. It doesn't just out the gate, you know what you're doing. I talked about, setting up access points in your house and stuff like that. I have problems too because, my connection is in the house. I've tried to create a mesh network outside in my woods. And, one thing I've noticed is like in the winter months, I get a really good signal because there's like no traffic. There's no, nothing blocking my signal. But in the summertime, it's the opposite. I have so many interferences with everything growing in. So it's something I'm learning myself that I have to come up with a better strategy to make it work. So this and the following sections examine the fundamentals of wireless networking. So the 802.11 standard and its family, the 11B, the 11A, and the 11G, and how they are configured. So starting off with the 1.1 wireless LAN standard, defines the following. The physical layer. Okay, what's the physical layer? What's the MAC layer, the media access control layer? What's the MAC management protocols and services? So those are the first three layers of those components. So the physical layer defines the method of transmitting the data. It's like, how is the data transmitted? What is it's the signal that's being transmitted. So is it RF? Is it infrared? So it depends on the type of signal that's being controlled. So there's typically 4 physical layers that are involved. There's the DSSS, which is the direct sequence spread spectrum. There's the frequently hopping spread spectrum, and I'll talk about these here in a second. And then there's the infrared, and that's more or less like it's a wavelength just greater than the red and visible light spectrum, but less than the microwaves. Does that make sense? Probably not. But it's just a different way. At one point in time, it was the only way that was available in order to provide a wavelength. When we talk about going back to the DSSS, which is the direct sequence spread spectrum, that one's a little bit different. Technically, it's used to reduce overall signal interference. So if there's other interference signals, it's more or less a way to make the signal wider in bandwidth than information bandwidth. So think of it as just a data signal that's sending a signal or wave, and it combined with a high amount of data rate bit sequence. So if like we're uploading a video, large video, 2, 3, 4 gigs or something like that, and we need to connect to the Wi-Fi to do that, or the Wi-Fi needs it, send that signal to be able to make that work. There's definitely a lot involved there. So think about the different sequences, because that one's using a wider bandwidth. It's pushing a lot of data out, where the infrared is using a more conventional method, but it has, so you can see the advantages and disadvantages of some of these. But as you see, the DSSS is most often used based off the way that it's designed. Now, we talked about the frequency hopping spread spectrum. Now that one's a little bit different. It's more or less a method of transmitting radio signals by rapidly changing the carrier frequency among the different frequencies. So for this one, is it the right one for what we're trying to do in technology? Maybe not. But is it the right one for a different type of service, such as radios that police officers use, firemen use? Maybe that might be the right spectrum for them, but not for internet signals. So there's different signals that are used for different purposes. And then lastly, we're talking about the OFDM, which is the orthogonal frequency division multiplexing. That one's a little bit different as well. And that one's it's basically assigning subsets of subcarriers to individual tenants, and this allows simultaneous low data rate transmission from several users. So, for example, the usage of this would be like if we're using the IEEE 802.16, or if we're using the 802.11ax. Those are wireless standards. So it is used in certain mobilities, but other areas it's not used as wide. So it just depends. So 2.4 gigahertz frequency range used by the 11B is shared by many technologies, including Bluetooth and cordless telephones, which maybe that doesn't use as much, and other wireless LAN. So these emissions can affect wireless data transmission. So 2.4 gigahertz is frequently used for that version of it. Another one is 11G. So another IEEE 802.11 wireless standard is for the 11G. Its standard supports a higher data transmission rates of 54 megabytes per second, but operates in the same 2.4 gigahertz range has 802.11b. So one of the things that is interesting here is you're learning how the standards only support a certain amount of transmission. The key thing here is, when these were available, so for example, I'm trying to figure out when trying to remember when the 802.11g came out, was released. It was released in 2003, I think. So going way back here, 2003, I think 2002, I got my first high-speed internet in my home, which was cable modem. I mean, up to that point, I had dial-up. And the speed, the most that you were able to get, I think, was 2 megabytes per second, which, that, as I mentioned before, based off of time, at that time, internet was still just started up. In my book, it's, in reality, it's been out for 10 years, but maybe the last 5 years it got really popular. And what that means is people weren't building gigantic things in 2002 yet. Facebook wasn't out yet. All the social media wasn't out yet. So things weren't happening the way they're happening now. So this worked fine. It allowed for some room to climb. 54 megabytes per second. You weren't getting that on you weren't getting that locally, and you weren't using this in the business, because businesses were wired at that time. They weren't using wireless technologies. Now, however, there were some small businesses that were using it, but they didn't need that speed. So that's just an example. Sorry. So the 802.11g equipment is also backward compatible with the 11b. So this means that the 11b wireless clients will be able to communicate with the 11g access points, and the 11g wireless client equipment will be able to communicate with the 11b. So what that means is, if you have these access points set up, you don't have to get rid of them. You can simply use that same technology. So it's like, it's backward compatibility, which is great. The obvious advantage of this company with 11b wireless network will be able to migrate to a higher data rate provided the 11g without sacrificing network compatibility. So, we know that network's going to work. They don't have to replace it. They don't have to start from scratch, so it works great. But most new wireless equipment support both 2.4 and 5 gigahertz standards. So there are some drawbacks with that. So one of the things with the drawbacks with the 2.4 and 5 gigahertz standards is some devices only support one or the other. So for example, I have a Sonos speaker for my television, and when we set it up, we couldn't get it to set up because it was using Wi-Fi, and I had to set up another network under a 5 gigahertz versus 2.4 because it didn't support 2.4. So that was the only way that I was able to initially get it paired, was to set it up on a 5 gigahertz network. Then after it was established, I was able to let it connect to a 2.4 gigahertz network. It's crazy, but that's how I had to work. Another entry into wireless networks is the 802.11n. So technology can operate in the same ISM frequency as the G, and can also operate at the 5 gigahertz band. So that's unique right there. It was an improvement to the multiple input, multiple layer output. So it improved the process. So it improved it. And this actually came out in, I think, 2009. So now we're fast forwarding. Here we are. Internet's been around since, I think internet officially, obviously for Signal 1968, but 2000, like we're saying 1992. I like to say 1995 is when it really became popular. It started to pop up in more places. So here we are, almost 15 years into the internet, and things are improving. So the 11 family, the AC family, all operate under 5 megahertz, or gigahertz, sorry. It uses a new version of the MIMO technology with 8 spatial streams, and has a chance up to 80 megahertz. So the 802.11ac incorporates standardized beamforming. And beamforming is a technique that is used to provide a direct transmission versus one that has to go through certain standards or certain locations. It has to hop in certain areas. The benefit of increasing data throughput while reducing the power consumption. So you're using less power, increasing more data. So Wi-Fi. Wireless networks also go by the name of Wi-Fi, which is what we're used to. So Wi-Fi Alliance stands for Wireless Fidelity. If you told people, hey, I'm getting on the Wireless Fidelity, they'd say, I don't know what the hell you're talking about. So Wi-Fi Alliance is an organization whose function is to test and certify wireless equipment for compliance with the 802.11x standards. So as you see here, these are changing, getting further on. 802.11x basically refers to this group of evolving wireless local area network, the WLAN standards that use under the development as elements of the 802.11 family of specifications that must but have not yet been formally approved or deployed, etc. So something to think about. So here are the wireless standards. We have the 11A, wireless A. Data transfers up to 54 megabytes, as we mentioned. Operating range is 75 feet. So this is key as well. You have to make sure that the network that you're using can get up to a certain range for it. And that's why access points come in handy. 11B, 11 megabytes per second. So, that is a slower, but you notice the ranges are 100 to 150 feet. So they're further, but they are slower because, and you look at the difference, 75 feet, 54 megs, man, that's awesome. That's half the distance, but now you're spreading. And so what's happening is that signal is getting weak as it gets to the end. And then you get to 11G and it ranges up to 150 feet at 54 megabytes per second. So now you've upgraded. You came up with something that could compete with the wireless A, but also extend out further. Then you have the N, which does 200 megabytes per second, which is great because carriers like your Comcast, your Xfinity, whatever, your Verizon are offering these mega deals, these mega plans where you get a gigahertz. But that's awesome, but you're never going to get it because some of these carriers can't support it. Like the wireless N, it can't support any, well, it says 200 plus, but it's not going to support a gigahertz. And then you get the 11AC, which data rates up to a gigabyte per second. Now that's where we're at today, where this is possible. We're getting these types of signals. We're getting, and I think the AC came out in 2013. Here we are 9 years into that or whatever, and it's able to get up a gigahertz. But you think about 2013, who was able to get speeds at 100 megabytes per second? I don't even know. If you weren't using a T1 in your house, it probably was impossible. Then there's the I, which is the standard, provides improved data encryption for networks that uses all the other ones that are listed here. And then there's the R, which is a standard designed to speed handoffs between access points or cells for wireless LAN. So getting back to the I for a second, this one's been out for a while, but it improves data encryption. So this is like back in 2004 timeframe. So as you see, we're going backwards here. It did improve over time, which was important. And then like the R was something came out in 2008, right before the 2009 one came out, and it did provide better access points. So we talked a little bit about the MAC, what that is at this point. We understand that it's just a unique value on your computer or device. Basic service sets, BSS. The basic topology is a wide local area network, as we mentioned before, and this is also independent basics set for ad hoc network. So I'm not really going to go through this because I feel that we've talked about this already a little bit. Access points, we could talk a little bit about this. So you know, as I mentioned before, you could have a wireless point. It depends. Everyone has something different. You could have wireless access points that are very small devices that plug into an outlet somewhere, and they're just a way to send signal. So, you know, you have your wire LAN right here, and then you have an access point here, you have one over here, and they're all competing with each other, or not competing. They're all connecting with each other, sending that signal. So why do you need an access point? So, you know, we talked about the different ranges of the wireless networks and how they only could do so many feet. So by having that access point, what it's doing is it's picking up that signal where it's being, say for example, let's say that we have, we'll say that we have a yard that's 500 feet long, and you know that you have something, you have an IP camera back there that you want to get a signal to. But the problem is, you know that your router signal is not going to be able to, it's not going to be able to read that connection at all. So you're going to need an access point in between there, maybe a couple of them, because based off the range. So, you know, going back here, let's say that we want to use, which one we want to use here. So, okay, the 11AC does a gigabyte, but what's the distance on it? So, you know, we look at, let's see, 11AC, let me figure out what the distance is on it because I can't remember. 11AC is actually 235 feet. And the N is 235 feet as well. So those both can go up to 235 feet, but this is providing a stronger signal. So in this case right here, we use the AC, we could get rates up to gigabyte per second. Now, you know, your carrier is not always, it fluctuates. So you actually just need one access point because it could send the signal 235 feet. Maybe you have one 150 feet out, it sends a signal, but if you're doing 500, maybe you need two of them. So you kind of get my point here. You don't want to lose that signal. You don't want it to die off and then you lost it. So that's important. All right, so that's that point. Problem with basic service set is mobile users can travel outside the radio range of the station's wireless link with one access point. Solution is to add multiple access points, as I mentioned. The more you have, the better the network's going to be. Mobile computer will establish an authorized connection with the access point that has the strongest signal level. As mobile users move through the signal, the strength of the signal from AP1 will decrease. At some point in the mobile user's travel, the signal strength from AP2 will exceed. So talking about wireless LAN design, an example of a basic 802.11b wireless LAN configuration is shown. Each PC is outfitted with a wireless LAN adapter card. The wireless adapter is a device that connects the client to the wireless medium. The medium is typically a radio wave channel and 2.4 gigahertz ISM. Instrumentation, scientific, and medical band. So as you can see here, we have the two PCs, we have the LAN, we have the Ethernet connection, we have the hub right here, we have the access point, and we have these other access points that are communicating to it. This could be your conventional thing that you have at home. You might have your PC hooked up to, you have a switch hub, you have your Ethernet, you have your access point somewhere connected to it, and it's sending off a signal. That's typical. All right, let's see here. So that's the same thing. SSID. Question comes up at a point. How does the access point know that the wireless data packet is being sent from a client in the wireless LAN? Answer is the 11 wireless LAN device is used as an SSID to identify what the wireless data traffic can connect to the network. So the SSID is a wireless service set identifier. So if you ever go to set up your network, I'll ask you if you want to show your SSID. I don't publish it because I don't want people to know what it is. And this just allows to show that your network's out there. Text states that it's a password that enables a client to join the wireless network. So it's just, you go to log on. Some of them are different. So if you're at a hotel, it's a lot different where you have to It'll say that you're connected, but then you have to pull up a website, and then you have to go through the website, read through the instructions, say blah, 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 you agree to this, you sign in, boom, you're good. Some hotels make you pay for it, so you have to provide an access code in order to do it. The term used to describe what a wireless connection has been obtained, and it's called an association. Wireless bridges. These are a wireless bridge is a popular choice for connecting LANs and running similar network protocols together, even if the LANs are miles apart. So figure A. So remember when I talked about how Point Park has their buildings separated, they're using T1 lines. They also could set up these bridges, which is sending a signal from point A to point B. So let's say you're sending a signal from the West Penn over to, say, Lawrence Hall. I don't know how their network's designed. I don't know what they're doing, but that could be one way that they're doing it. They could have antennas on their roof sending signals over. Connection to the wired LANs. So this just shows you the rooftop antenna. So if there's an antenna, look to see if you see something up there. That is an easy way to send it, but there are some challenges with that as well. So wireless LANs have a maximum distance that the signal can be transmitted. This is a critical issue inside a building when your user mobility is required. There are many obstacles that reflect and the signal from causing reception to suffer. Also, the signal level for mobile users is hampered by the increased distance from the access point. So distance is also a critical issue outdoor point-to-point, multi-point wireless networks, and I've had that same problem. Indoors, you can have multiple access points within a facility as shown. The mobile client will be able to maintain a connection as he or she travels through the workplace, since the wireless network will automatically select the access point that provides a strong signal. So when using access points, it's important that you use the same SSID network. If you use different ones, it gets confusing. RF study, it is important to verify that the RF signal level is available for the users in the wireless LAN. This is the best accomplished by performing a site survey. Inside a building, a site survey is performed to determine the best locations for placing access points, for providing maximum RF coverage for the wireless networks. Site survey. Indoor, you want to check. So the key issues to be attained from the site survey would be what is your electrical power? What's the wireless network connection points? Access. No, these are ideas for your assignment as well. Access point replacement. What's the RF coverage? What's the bandwidth supported? And then outdoor is the same. Your basic access point, connection back to the home network, antenna that you selected, the bandwidth, and so forth. Here's an example of a site survey that was conducted by determining the placement of an access point to provide the wireless network connectivity of a building. So you can see here you have different pinpoints here, and the objective here is to provide a mobile client access throughput. The building already has 2 wired connections available for placing an access point. The floor plan for the building is provided. So these are important to identify where there's going to be a conflict at, and how do you get over the conflict. This is in point A right here, that the data speed is 11 megabytes per second. This will change if the signal level decreases significantly. The wireless PCMCI card also comes with a way to check the signal statistics. So there's a way to check the stats. And there's actually an app out there that allows you to do the same thing. I don't remember if I have it on my phone. I'll tell you what it is. It is actually pretty cool. I might delete it. Wi-Fi. Oh no, I have it. It's called Wi-Fi Sweep Spots. Wi-Fi Sweet Spots. Sweet Spots. And what you could do is you could take your connection. I'll actually put a screenshot of it in the lecture here. And it shows you your area of signal and so forth. So it's actually pretty cool, to be honest with you. I'm going to send it right now. If I can. All right, hold on. Let's do this for a second. AirDrop. There we go. Send it to my phone. Hold on. Waiting. Oh, there we go. And accept. And let's see where the hell it went to. There we go. All right, so here is the. I just screenshot it and put it out here real quick. But this is this thing that I use, Landshark, is my phone. So it shows that I'm picking up 395 megabytes per second. It's dropping off. Now I'm not even moving, so this is a good thing to move, and you could walk through your yard. So actually, what I'm gonna do is I'm going to pause this video, and I'm gonna walk through the back of my yard, which is so many feet away, and we'll see what it looks like. So I'll be right back. So I'm making this lecture pretty good, guys. Interesting. So my network died on me and went to my other network, and it just died out. You see, it wasn't even 35 megs per second. It was like, I don't even know, maybe 17. It just died out. So as you can see, my network needs to be fixed. Now I don't have cameras as far out anymore. They're gone. But I do have some that are in the woods. So I went probably maybe a couple hundred feet from my house. So don't mind the grass I need to cut. But that is probably 200 feet from the house. I actually have an IP camera that's sitting right up in here somewhere. And I'm surprised that it did not. I'm actually going to check on it right now to see how it's looking. But back in. As you can see that I lost connection somewhere at some point. And I'm actually going to check on the woods to see how it's doing, if it's even connected. So it's actually interesting because I'll send you another screenshot. If you see the signal, so there's definitely some challenges that I didn't realize was happening because I haven't had time to play with it. Let's see, accept it. See the downloads. So give me a second here, I'll show you what I'm talking about. So it's trying to connect to the, you look at the signal right there, it's getting a bad signal. So it is trying to connect to it. Usually it'll tell me the signal speed on it. But I am not seeing it. Now I have it at high def, 4K, but it's actually having a hard time. Oh, okay, it's playing somehow, I think. Yeah, it's working, but the signal is really bad. So you can see like right here, it's just like one bar. Now the other one is closer to the network, but it also has one bar too. So there is 100%. Oh, maybe it's maybe 2 bars. Here, I'll show you. Bear with me. This one's closer to the network, but it's still having some problems. It's open. All right, so this one is the top of the woods. Yeah, that was a big tree that fell that day. But you see here, we're getting 2 bars, so it's giving a little bit better signal because it's closer to the houses over here somewhere. So it just depends. Anyways, I wanted to include that because I thought that would really enhance our session that we got going here. All right, let's pull this back up from current slide. I'll make sure I'm still recording. Give me a second here. Yep. So recording at 44 minutes. All right. So I'll go through that because I already talked a lot about that right there. But you can see you can use the Wi-Fi. You can use your tablet. It'll tell you speeds. There's something called speed test. We'll give you speed as well. So next section, this section looks like 3 different wireless technologies. They use Bluetooth, WiMAX, and RFID. So Bluetooth is, I think we all use Bluetooth for something. It's an awesome technology. Can something else be better than that? I don't know. It'd be nice if someone came up with something cool. But it uses 2.4 gigahertz. It's using the 11B, G, and N network. And so the maximum output power and operating distance. The caveat to this one is the distance. It's not the best distance on Bluetooth. It only works for a period of time. So I'll give you an example. A lot of times I'll have my Bluetooth or my AirPods in. And so like when I go to the kitchen, which is on the other side of the room that I'm in right now, I get sometimes the signal just does not travel to the wall. And sometimes it'll be fine. And sometimes it's not. It kind of skips on and off. So it's difficult to go from point A to point B. All right, so inquiry procedure. So this is when Bluetooth device is enabled. It uses an inquiry procedure to determine if any other Bluetooth devices are available, and if it could be discovered. You can't have multiple things connected at the same point. So like, let's say you're connected to a speaker and someone else wants to connect to the speaker. The only way that works is you have to disconnect or it will not work, which is good. I won't go into detail. I think we've all used Bluetooth in some areas, and for our AirPods, wireless speakers. I use it for Alexa. I'm able to connect to her on my computer and use that as my speaker instead of my computer speaker, which is nice. WiMAX is a worldwide. It's a microwave access that provides a broadband wireless system and has been developed for use of broadband wireless access points. It can be fixed for mobile stations, and we'll be able to provide a wireless alternative for the last mile broadband access. So this is something that could be used for up to 30 miles. Like I said, drive down to 300 Corliss Street, Pittsburgh, PA. That's the address, and drive through the Comcast parking lot, and you'll see through what it is, 3 or 4 gigantic. Let me see. Actually, let's see what we can pull it up. I might be able to pull it up. Bear with me. Corliss Street. So this we got a little Google about. So let's see if they are there or if we can even see them. Surprisingly, let me go through the parking lot. There they are. All right, so there's more than 3. I had it off. Look at that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, they even have 11. So they've expanded since I worked there. 12 maybe. So 1, 2, 3. They've definitely expanded since I've worked there. So let's get a better idea. So we know there's 3 there. All right. We need to get out of here. All right, so there's 1 there, 2, 3, 4, 5, 7. You get my gist. These are the satellites that they use for their signals. So very cool. Check that out if you ever have a chance. WiMAX worldwide. So we talked about that. As you see, it talks about this could be useful in situations where DSL or cable network connectivity is not available. So this could be something that could be helpful. So radio frequency identification technology, just to kind of speed up the lecture here. That could be used for like your a lot of times it could be used for your radios, antenna integrated circuit, so RFID system. You also could see RFI if you ever heard of something called RF tags. There's these tags that you can tag your device. I think Apple has one out now, and you can tag a device, like put it on your wall or whatever. So if you lose it, you can easily identify it through the RFID system. Power tags, that's what I was just talking about. Mobile communication. So LTE is like your speeds, long-term evolution. Now we have 5G, which is there's 5G and 5G Ultra great, something like that, ultra something, and it's a faster speed. This section right here presents an example of preparing a proposal for providing a point-to-point, multi-point wireless network for a company. Overview, conducting an initial antenna site survey. So doing a survey, identifying a link between the home network, configuring a multi-point distribution, conducting a RF site survey, and configuring a remote user installation. So this is kind of the stuff that we talked about in my backyard, so that could be very helpful. But you're using an antenna instead. So you do your survey, you identify what your type of selection. So you have these three different antennas here based off of megabytes per second and cost. And then you have to figure out what signal that you want to use. So these are different patterns that are available. So just imagine the signal is coming, identify what could be more helpful. So, here's some examples. You have your Yagi, you have your Omni. You'll see, this one's more often. You can see, if you click on the link, it'll go out to this link here. But if you look around, this is more. You'll see this more often than this, and this parabolic. I've seen it. You'll see those around as well. So I don't know if that's it. Yeah, that's it. So there was a lot there that we went through, kind of streamed through this last aspect, but I tried to make this as logistic as possible by going out in the yard and doing a survey of the property. So you see I got some problems and I need to fix it. So I'll update you on that. But anyways, so you have your information for a week. Once again, no in-person class. This should actually suffice that. There's no lab because it's up to you to read through the material, what you learned this week in the lecture, and then also set up a group if you want or do it yourself. But I look forward to seeing you guys here soon in a couple weeks. Thanks and have a great day.